Hello, thanks for tuning in. This is the first of a series of demonstration videos meant to show some of the basic functionality of the Omniot SoftHub platform. We're going to try and keep each demo video very short. For each example, we'll go through the actual configuration process followed by a very quick live demo. Keep in mind that while each demo is somewhat contrived, the main goal is more to highlight some of the SoftHub's capabilities versus demonstrating any specific real-world application. So let's get started. In this first demonstration, we're going to show how easy it is to configure the SoftHub to perform one of the simplest, yet also most common and useful IoT application requirements. We'll configure the SoftHub to connect to two sensors, a Garmin Tempe sensor, which is an ANT sensor, and also a Texas Instruments sensor tag sensor, which is a Bluetooth low-energy sensor. Then we're going to have the SoftHub forward every raw sensor packet it receives to a remote Amazon AWS cloud server over a TLS encrypted connection. On the AWS server, we're running the SoftHub packet capture service, which will decode the incoming packets and write them to the screen in XML format. In this demo, we're not going to go into a lot of detail as we create our rule set. But don't worry if it's not very clear. In the next video, we explain the rule set objects in depth and describe how they interact to control the SoftHub. To get our SoftHub configured, we'll first run the SoftHub configuration utility to create the ruleengine.xml file. We'll then copy that file to the appropriate directory on the SoftHub device itself. And lastly, we'll restart the SoftHub daemon to process the new configuration file. This is the SoftHub configuration utility. As we're building each object in the background, we'll display the finished object in the foreground and briefly describe how it's going to be used. So let's get started building the configuration file for example 1. First, we'll set the global option to automatically connect to any sensor object we define. We could also connect the individual sensors explicitly in our rule set, but for the demo series, we want all sensors we define to be always connected. Next, we'll define our sensor stream objects, which will describe to the SoftHub the physical sensors we want to connect with. This object tells the SoftHub we'll connect with an ANT sensor running an ANT environment profile. We didn't set a specific sensor ID, so the SoftHub will connect to the first sensor it finds of this type, which in our demo will be our Garmin Tempe sensor. Lastly, we've specified an event object to be queued every time a new packet arrives from any sensor that gets connected through this sensor stream object definition. Now we do the same thing for the Bluetooth low-energy sensor tag sensor. The only significant difference here is the Bluetooth low-energy sensor requires us to explicitly enable any sensor value we want to receive. We've enabled the sensor tag's light sensor, which reports ambient light in lumens. And as with the previous definition, we associate an event to be queued as the packets arrive from the sensor tag. Now we'll define the two action objects we'll need to actually carry out the forwarding of our sensor packets to the remote AWS server. First, we'll create one for the ANT sensors packets. In this definition, we're telling the SoftHub that we want the most recent packet received from our sensor connected via the named sensor stream object to be forwarded to the remote IP import address we've specified. We've also enabled packet caching so that any time our connection to the remote server drops, we save any interim packets to be forwarded once the connection is reestablished. So again, here we've done the exact same thing for what will be our sensor tag sensor connection. Looking at the currently defined event objects, we see the two events that were created when we defined our sensor stream objects. The first one will be queued every time a new packet arrives from the Tempe sensor. So we'll define one rule object to be evaluated every time this event gets queued. Here we define a rule that says when the triggering event occurs, execute the action object we previously defined to forward the most recent Tempe packet to our remote server. Next, we'll do the same thing for the sensor tag sensor. And that's it. We've created two simple rules that effectively say, when a new packet arrives, execute an action object that will forward the packet to our remote server. So now we'll save the file and push it to our SoftHub device. Here we use PuTTY's PSCP command, but you can use any method you're comfortable with. And now we'll SSH into our hub device and restart the SoftHub daemon. And then switch over to our remote desktop session logged into our AWS server. As the sensors connect, we'll see the decoded packets being displayed. Here are our two sensors, which are sending packets to a Raspberry Pi Zero device running the SoftHub application. The Raspberry Pi is connected to our router through the Wi-Fi and is forwarding the sensor packets to our AWS cloud server. The laptop has a remote desktop session into the AWS server so we can see the new packets as they arrive and are decoded. And lastly, here's the decoded packet from the Tempe sensor and another from the sensor tag. That wraps up our first demo. As previously mentioned, our follow-on video in the link below explains in more detail how the rule set rule objects work to control the SoftHub application. The link for that video, along with links to the other demos, are in the video description below, and of course, if you have any other questions, we've included our contact information as well. And thanks again for taking the time to check out the Omniot SoftHub platform.